Welcome students. Today we are going to cover notes to 12.2, which is the surface area of prisms and cylinders. And again, in this one I'm going to give you the picture, I'm going to give you the definitions, and we're going to come up with the words. Alright, this first picture is a three-dimensional shape. We call it a polyhedra with two congruent faces, called bases, that lie in a parallel plane. So when we have that situation happen, we call this a prism. Okay, next. It is parallelograms formed by connecting the corresponding vertices of the bases. So it's going to be these around the shape. Not the top, not the bottom, but just these faces around the shape. So those are called the lateral face. These parallelograms are all lateral faces. Right? It's not the top or the bottom. It's not the bases. It's all the other ones. The segments connecting the corresponding vertices of the bases, these are called the lateral edges. Alright, when we take the sum of all the areas of the lateral faces, just the ones that go around, not the top or the bottom, that's going to be a type of surface area. We call that the lateral surface area. Okay, and then when we add in the top and the bottom, the sum of all the faces, the areas of all the faces, so it's going to be the lateral surface area plus the top plus the bottom, we call that surface area. Some of you may have heard it called the total surface area. Those are the same. Alright, so now when you take this shape here and you take it apart and you flatten it out and it makes this two-dimensional picture over here, we call that a net. It's a two-dimensional representation of the faces of a polyhedron. Alright, a prism where each lateral edge, so each one that goes around it, the front, the back, the side, and the side, they are perpendicular to both bases. So that's what all these right angle marks are. When each one of those faces is perpendicular to the top and the bottom, we call that a right prism. Okay, so when a prism where each lateral edge is not perpendicular to both bases, so when it's like this one where it's leaning over, we call that one oblique. It's an oblique prism. Okay. Alright, next page. Now in this one, we have two more vocabulary terms. At the top, a solid with congruent circular bases that lie in parallel planes. So these two are parallel. So that's going to be called a cylinder. And then when you can connect the center of the top base and the center of the bottom base, and it's going to be perpendicular to both bases, then we call that a right cylinder. It's not oblique, it's not leaning. So it's a right cylinder. Okay, so now, surface area of a right prism theorem. So the surface area S of a right prism is, and this is on your formula chart as well, it is the top and the bottom base, the two bases, 2 capital B, plus the lateral surface area. So 2 bases plus the lateral surface area, and to get the lateral surface area, we take the perimeter of the base and we multiply it by the height. So that's going to be perimeter times the height. Now, if you don't know one of these edges, we're still going to use the apothem. So here, this is going to be the apothem times the perimeter plus perimeter times the height. Okay, because there's two of them. Because remember, to get that area down there, that was the apothem times the perimeter divided by 2. But since you have two of them, that's why we get rid of the divide by 2 and just call it the apothem times the perimeter. All right, next we have surface area of S of a right cylinder. Well, the surface area of a right cylinder, that's the two bases plus your lateral surface area. Okay, so I'm going to put lateral surface area right here. Lateral surface area. And to get that lateral surface area, we find the circumference of the base, the circumference, and we multiply it by the height, which is the distance between the two bases. All right, so we can rewrite that as 2 times, and then the shape of the base is a circle, and when we are talking about the area of the base, that's going to be pi r squared. So we have 2 of those. Pi r squared plus circumference is pi times diameter, or 2 pi r. So that's going to be 2 pi r times the height. All right. So now time for examples. So we have 3 examples and no pictures. So here's how to do it without pictures. All right, we're talking about a right rectangular prism. So if you want to look at your vocabulary terms and look and see what it looks like, feel free to do so. So that was on your notes 12.1. But here, it's just like a shoebox. It has a top, bottom, a front, back, and a side, side. Okay, so that's what I'm going to list. I'm going to list all the sides. That's going to be front and the back. The front and the back are the same. The top and the bottom are usually the same. And the right and the left sides. Okay, so the front and the back, I'm just going to take 2 of the dimensions and multiply them together. So these dimensions for the front and the back are going to be the same, so it's going to be a 5 by 11 rectangle. The top and the bottom are going to be the next 2, so that's going to be 11 by 4, and then this one side is going to be the leftover, so whatever combination is left. So that's going to be the 5 and the 4. Now when I multiply these together, I get 55. But remember, there's 2 of them, so that's going to be 55 times 2. So the front and the back, when I work that out, it's going to be 110, and that would be feet squared. The top and the bottom, that's going to be 44, but remember there's 2 of them, so this one's going to be together, that's going to be 88 feet squared. All right, one side is going to be 20, but both of them together, that's going to be 40 feet squared. Now, to get my total surface area, I'm going to add all of these up. 110 plus 88 plus 40. That makes 150. 150 plus 88, that's going to be 238 feet squared. And that's how to do it without a picture. It's just labeling all the sides. The next one says, find the surface area of a right cylinder with height 9 centimeters and a radius of 6 centimeters. Round your answers to the hundredths place or 2 decimal places. Okay, so you can try drawing over here to the side, drawing a little picture of it. I know that my radius is my radius is 6 centimeters, so radius is 6 centimeters, and my height in between is 9 centimeters. Okay, so the surface area of a cylinder, surface area is the two bases plus the lateral surface area. Now remember the two bases, that's going to be 2 times pi r squared, and the lateral surface area, that's from right here, the lateral surface area is going to be 2 pi r times the height. Now all I have to do is plug in what I know. So that's going to be 2 times pi times 6 to the second power. 6 squared is 36, so that's going to be 36 pi is what I'm going to put here, plus 2 times the radius, that's going to be 12 pi, times the height, which is 9. So if I multiply these two numbers together, okay, and write it up here, that's going to be 2 times 36, so that's going to be 72 pi, plus, multiply those two numbers together, and when I multiply those two numbers together, I should get 108 pi, and now that says 72 pi plus 108 pi. So how many total pi do you have? Well, you just add the 72 and the 108. So 72 plus 108, that should be 180 pi. So this would be called my exact answer. But they wanted me to round, so I plugged that into my calculator, and I get approximately 565.49 centimeters squared. Okay, this next one I'm going to do on the back, it says, find the radius of the right cylinder with height 5 inches and surface area, which is 168 pi inches squared. So, on the back, my height is 5 inches, and my surface area is 168 pi inches squared. Okay, so what I'm going to do is I'm going to start with my formula. Surface area is going to be 2 times pi r squared plus the lateral surface area. Remember, this was the two bases, and this was the lateral surface area. So that's going to be the circumference times the height. Circumference is 2 pi r. Alright, now plug in everything that you know, which is not a lot. So this one over here is going to be the 168 pi. This one right here is going to be, I don't know anything else, so that's just going to be 2 pi r squared plus, this one here is going to be 5. The 5 goes here. So that's going to be 2 pi r times 5. Alright, clean up what you can. So there's nothing to do here, so I'm going to write down 168 pi. There's nothing to do here, so that's 2 pi r squared plus, these can be multiplied. That's going to be 10 pi r. Now that looks confusing with all those pi symbols in there, and notice how each one has a pi symbol. So I'm going to divide both sides by pi. So I'm going to divide this by pi, divide this by pi, and divide this by pi. Here you would factor out a pi, so, or divide each term by pi. So here, these cancel out. And that'll make it a little less confusing. That's 168 on the left-hand side, 2r squared on the right, plus 10r. Now, if you don't recognize it yet, change the r's to x's, and you might recognize it. 168 equals 2x squared plus 10x. It's a quadratic. And in Algebra 1, we learned to move this 168 over to the left-hand side. So, and rewrite it. That's 2x squared plus 10x minus 168. And remember, that's equal to 0. And to find x, we had to factor it. Well, that's a big number. So there was another way, whenever you had difficult numbers, there was another way to find out what x was. And that was called the quadratic formula. And remember That is, it goes to, you can sing it, it goes to the song of Pop Goes the Weasel, and it goes like this. X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. And so that's how, when I taught Algebra 1, that's how I taught my kids how to memorize that. So here, if you look at this quadratic, you know that your a is 2, because that's the coefficient. B is 10, and C is negative 168. So plug this information into this equation. So that's going to be x equals a negative b, that's negative 10, plus or minus the square root of 10 squared minus 4 times a times c, all over 2 times a, which is 2. Alright, we've got a lot of cleaning up to do. So here, I'm going to just rewrite this as negative 10 plus or minus the square root of, that's going to be 100. And then when I plug this into my calculator, that negative times a negative is going to make a positive. So that's going to be plus. And that's 4 times 2 is 8. 8 times 168. That's 1,344. And then 2 times 2 is 4. Alright, so we got still some more cleaning up to do. That's going to be negative 10 plus or minus the square root of, add those together, that's 1,444 over 4. Now if you take that and plug it into your calculator, it reduces. So that's negative 10 plus or minus, that's going to be 38 over 4. Okay, at this point what you should do is split it apart. So you should write negative 10 plus 38 divided by 4 and negative 10 minus 38 divided by 4. So it's going to be both of those answers will work. But remember, we're looking for a radius. Okay, so way back up here, we're looking for r, which is the radius. So we're looking for a distance. So we can't have a negative answer. So that's why this one's not going to work for us. So over here, when you take negative 10 and 38, that's going to be 28 divided by 4, which equals 7. So my radius is 7. And then look and see what label you were using. That would be inches. Okay, so flip it back over here and write that down. That's 7 inches. Alright folks, that's it for notes 12.2.